Good morning, students. Today we are going to solve the uh, s- today we are going to solve the problem by using the how to find the centroid of a uh, quarter circular arc by using the first theorem of Pappus as shown in the figure below. So here he has given data is the surface area of the sphere is 4 pi r square. So if you rotate this quarter circular arc either about x-axis or about y-axis, the surface area surface area will be generated. The generated surface it will surface area will be generated. If you rotate about x-axis or y-axis, it forms the hemisphere or half of the sphere. So now now we need to find the generated surface area of the hemisphere, that is equal to the 4 pi r square by 2. So if you look at this the given data, the surface area of the sphere is 4 pi r square. The area of surface generated by revolving the quarter circular arc about either the x-axis and y-axis is that of a hemisphere. Is that only half of the sphere will be formed. So the generated surface area is equal to 4 pi r square by 2 pi r square. So 4 pi r square will be for the entire sphere. 2 pi r square is for the half of the sphere. Next, if you go for that one, see what is the length of the arc. What is the length of the arc? So we know that this is the arc is the quarter portion of the circular arc. It is the 1/4 part of the circle. So the we know that to enter the circumference of the circle is 2/4. We need only the 1/4 portion. So the length of the quarter circular arc is 2 pi r by 4. So now what is the first theorem of the Pappus? From the first theorem of the Pappus, the area generated is equal to the product of the length of the arc and the distance traveled by its centroid in one revolution. So you can write. So now let us assume that one you are rotating the circular arc about the x-axis. You are rotating about the circular axis about the x-axis. So it forms the hemisphere or half of the hemisphere that is equal to the product of the length of the arc multiplied by the distance traveled by its centroid during one revolution. Distance traveled by its centroid during one revolution. So if you see this one, during the one revolution, the distance traveled by the centroid is equal to the circumference of the circle as shown in figure. Distance this is the distance traveled by the centroid. That is the what is the radius of this one yc. During the one revolution, it forms the circumference of the circle. Now can usually apply by using the first theorem of the Pappus. What is the surface area is generated 2 pi r square. That is equal to the length of the arc. This is the quarter portion of the circle, quarter portion of the circular arc. So the 2 pi r is the circumference of the circle, but it is the 1/4 of the circle, 1/4 of the circle. So multiplied divided by the 4, multiplied the distance traveled by it the centroid during one revolution. So here it is the radius of the circle, the radius of the centroid is yc. So during the one revolution, the distance covered by the centroid, the point of the centroid is 2 pi yc. Now if you do the now if you solve this one, you will get yc is equal to 2r by 5. 2r by 5. So similarly, by rotating the quarter circular arc about the y-axis, so similarly the same surface area will be generated. The generated surface area is equal to the length of the quarter circle multiplied by the distance traveled by its centroid during one revolution. So here also the radius of the centroid during the one revolution of the arc is xc. So now similarly you write this one. So the 2 pi r square is equal to 2 pi r by 4 multiplied by the distance traveled by the centroid during one revolution is equal to 2 by xc. X is equal to r by 5. So this is the how to find the centroid of a quadricircular arc. How to find the centroid of a quadricircular arc. So if you have still any doubts, so here you have to remember that one. Here the length of arc is equal to length of arc equal to 2 pi r by 4. 2 pi r by 4. The entire circle for entire circle the circumference length is 2 pi r. 2 pi r, but in our case it is the only 1 by 4th part. It is the 1 by 4th part. So for that one length of the arc is equal to 2 pi r by 4. 2 pi r by 4. So thank you.